Hello students. In today's lecture we are going to observe the properties of non-metals and what are the different types of non-metals that you observe in the periodic table. So to do this observation, to observe their properties, we are given one particular activity over here. So in this activity they are asking us to collect the samples of carbon, sulfur, iodine, and whatever the activities that we did in the previous lecture, same things we are asked to repeat them, and we need to observe and we need to fill these recordings in the table. So here we fill up this table with metals as well as non-metals. We did this activity with iron, copper and aluminium. Now we are going to do with carbon, sulfur and iodine. So here the element and symbols you can write, and type of surface if you observe. If it is shiny, it is metal. If the surface is dull, then you have to say it is non-metallic. Coming to hardness. So if it is shiny, it becomes a metal. If it is dull, right, then you need to say it is a non-metal. Right. Coming to hardness, can it be scratched easily or it is hard? That you will observe. In general, metals are harder compared to the non-metals. Coming to malleability, so can it be beaten into thin sheets or not? That you need to test. Metals are malleable, that we learnt already, and ductility, can it be drawn into thin wires? Metals can be drawn into thin wires. So this is S for the metal. So basically these won't be happen with the non-metals. And conductivity, so will they pass electricity or not? They will pass, the metals pass the electricity, and the others. And sonority means that is, they produce a ringing sound when stuck. So metals have this property also. So you will observe that metals like iron, copper, they will be shiny in nature, they are hard in nature, they are malleable, ductile, conduct the electricity, and they produce ringing sound when tapped. Coming to non-metals, they are like sulfur, coal. So they are dull in looking, they are brittle, they are non-malleable, and they are non-ductile, and they are poor conductors of electricity, and they are non-sonorous. These are the properties of the non-metals. Okay, so did you notice that all the metals and non-metals follow the same pattern? There may be some difference that you need to observe. Coming to mercury, Hg, it is liquid at the room temperature, that we need to observe. And coming to graphite, it is a form of carbon only, but it is a non-metal, but it conducts electricity. Some exceptional cases are there. Those things are also you need to make a note of about that. Okay, here some observations you need to make. So all metals except mercury exist in the solid form, and that's what. And they have high melting points, but gallium and cesium have very low melting points. These are also exceptional. Coming to iodine, is a non-metal, but it is lustrous. Some exceptional cases, try to remember them. Carbon is a non-metal that exists in different forms. Carbon is a different thing. So it is called an allotrope. Diamond, an allotrope of carbon, is the hardest natural substance known and has a very high melting and boiling points. Graphite, another allotrope of carbon, is a conductor of electricity. Same carbon is behaving in different ways. When it is in the form of diamond, it is having particular properties. When it is in the form of graphite, it is showing another properties. Diamond is the hardest substance that you can see, and graphite is a good conductor of electricity. So these are the some unique behaviors of different materials. They are formed using by carbon. So alkali metals, lithium, sodium, potassium, are so soft that they can be cut with a knife. They have low densities and low melting points. Okay, these are coming into again metals. So some exceptional cases are there. Please make note about these materials. So now you will be having a doubt how we can identify or how we can classify So here some abnormalities are there in the behavior. The other option that we have is we go to the chemical properties of these metals and non-metals. Then you can identify based upon their chemical properties also. So here we are having a one particular activity. In this what we are doing is we are taking a magnesium ribbon, take small piece of magnesium ribbon and burn it in the air. So collect the ashes formed in the and dissolve them in the water. Test the solution with red and blue litmus paper. The solution turns red litmus paper to blue, so indicating it is a basic. So similarly, now burning sulfur powder, take some sulfur powder and burn it in air. Place test tube over the burning sulfur to collect the flames. Add some water to the test tube and shake. Test the solution with red and blue litmus. So here the blue litmus paper turns into red, so indicating it is acidic in nature. So here what you are learning is metal oxides. For example, magnesium oxide is a metal oxide, so they are basic. And non-metal oxides, for example, sulfur dioxide SO2, it is acidic in nature. General rule is metals react with oxygen to form basic oxides. These are basic oxides, and non-metals, they get acidic oxides. If you burn them, they are forming acidic oxides. So these are the observations in this particular activity, and we discuss about the questionnaire here. So give an example of a metal which is a liquid at room temperature. Just now we discussed about this. So HC, mercury is liquid in nature. Mercury is the only metal that exists in the liquid form at room temperature. Then can be easily cut with a knife. What is the metal that can be easily cut with a knife? Sodium and potassium, both you can cut with a knife, right? Metals that can be cut with knife. Iron and copper, these things you cannot cut with a knife, they are hard. So what is the best conductor of heat? Okay, silver is the best conductor of heat, that you need to observe. Followed by copper and gold, they are the next better conductors compared to silver is the best conductor. What is the poor conductor of heat? Lead is a metal, but it is a poor conductor of heat compared to the other material. So here they are asking all about the metals only. So compared to all metals, plumbum or lead is the poor conductor of electricity, right? So explain the meaning of malleable and ductile. What is that? You already know. The ability of a metal to be hammered or beaten into sheets without breaking, that is nothing but malleability. Example, silver, gold, aluminium, they are highly malleable. You can make them into sheets. That is the property of these metals. And what about the ductility? The ability of a metal to be drawn into thin wires. So here you can say copper, aluminium and gold are very good ductile. So the final conclusion is the activity here helps us to identify acidic and basic nature of the oxides, right? So here introduces the unique property of metals such as malleability, ductile and conductivity. So these things we discussed for today. Thank you so much. Bye.